On the left, the moon on Tuesday. On the right, the moon on Wednesday. That hole is 27 meters across. It did not exist 48 hours ago. It was made by a piece of a SpaceX rocket that nobody was flying, nobody was steering, and nobody could stop. And the strangest part of this story isn't that it happened. It's that we knew it was coming. We knew almost exactly when. And there was nothing anyone could do about it. Start with the object itself. This was a Falcon 9 upper stage, 4,000 kilograms of empty metal, about 5 stories tall, and by the end, completely inert. No fuel, no power, no transmitter, a dead thing in orbit. It got there on the 15th of January, 2025. That launch was carrying 2 commercial moon landers, Firefly's Blue Ghost and a Japanese lander called Resilience, built by s-ivb. Blue Ghost made it. It touched down successfully that March, a genuine milestone for private lunar landing. Resilience did not. It crashed on its final descent. But the piece of this story that matters is the rocket that delivered them. Normally, a Falcon 9's first stage flies home and lands. You've seen the footage. The upper stage doesn't. It's expendable, and SpaceX usually steers it back into Earth's atmosphere to burn up. That's the plan. It requires fuel, and on this mission, getting 2 landers all the way out to a high, moon-crossing orbit consumed almost everything the upper stage had. When the payload separated, there wasn't enough propellant left to bring it down. So it just stayed. For a year and a half, a 4-ton piece of dead rocket looped around the Earth on an orbit that crossed the moons. Nothing about that is stable. 2 forces went to work on it. The first is gravity, not just Earth's, but the moon's, tugging a little differently on every pass, reshaping the orbit slightly each time. The second one is the part people find hard to believe. The sun. When solar activity rises, Earth's upper atmosphere heats and expands. It puffs outward. Objects that were skimming clean vacuum start brushing against the very thin gas at the edge of it. And that faint drag, over hundreds of orbits, is enough to change where something ends up. Between the 2, the orbit shifted, and astronomers tracking it saw where the lines were converging. They calculated the date, they calculated the hour, they published it. And then everyone just waited, because there is no system on Earth for moving a dead rocket. Nothing to launch, nothing to push it with, nothing to grab it. We could only watch the arithmetic play out. At 6:34 GMT, on the 5th of August, 2026, it hit, not approximately. Right on the predicted time, it was traveling at roughly 8,700 kilometers an hour. That's about 7 times the speed of a rifle bullet. There is no atmosphere on the moon, so nothing slows an object down. Whatever speed you arrive at is the speed you hit at. And there is no explosion in the way you'd imagine, because there's nothing to burn. All of that motion converts to heat and shock in a fraction of a second. The result? A fresh crater up to 27 meters across and a plume of pulverized lunar rock thrown out above the surface. 4 tons of human engineering, reduced to a hole and a dust cloud. Here's where it gets good. South Korea has a spacecraft in lunar orbit called Danuri, the Korea Pathfinder Lunar Orbiter. It's been circling the moon since late 2022. It carries 6 instruments, including a NASA camera called ShadowCam that hunts for water ice in craters the sunlight never reaches. Korea's space agency did something clever. They adjusted Danuri's orbit in advance so it would pass over the impact site, and they started imaging about 30 minutes before the collision. 8 separate imaging passes, before and after. That is a genuinely rare dataset. Normally, when you find a fresh crater on the moon, you're inferring what happened from what's left. Here we have the surface photographed minutes before, the same surface photographed minutes after, and precise knowledge of the mass, speed, and angle of the thing that made the difference between the two. You can measure exactly how much material a known impactor throws, and how far. And there's a detail I can't leave out. Danuri reached the moon in 2022, launched on a Falcon 9. The same family of rocket that put the impactor up there took the camera up there too. NASA's Lunar Reconnaissance Orbiter will image the site next, and the datasets get pooled internationally. Observatories all over the world pointed at the moon that morning, hoping to catch the flash. The results are still coming in. A team at the Instituto de Astrofísica de Andalucía in Spain believe they captured video of the ejected material rising off the surface at the predicted moment. A telescope in Chile spotted the debris plume. But it's worth being honest about scale here. NASA Administrator Jared Isaacman pointed out that meteoroids strike the moon every hour. Impacts of roughly this energy happen about once every 6 days, entirely naturally. So the physics of this event was ordinary. What made it extraordinary was that for once, we knew the mass, the speed, the time, and the place in advance. And we had a camera in position. And if the idea of a rocket hitting the moon feels like a new kind of problem, it isn't. Not remotely. The Soviet probe, Lunar 1, in 1959, was built to hit the moon. It missed and sailed past into orbit around the sun. Lunar 2, 9 months later, did not miss. On the 14th of September 1959, it became the first human-made object ever to reach the surface of another world by crashing into it deliberately. America's Ranger 4 hit the far side in 1962, though not as planned. Its solar arrays failed to deploy, and it arrived dead. Then Apollo turned it into a method. From Apollo 11 through Apollo 16, NASA deliberately spent Saturn S 4B upper stages into the moon. Aimed at seismometers the astronauts had left behind. Known mass, known speed, known location, a controlled experiment. Each impact rang the moon like a bell, and the seismometers listened. That's how we learned the moon has a rocky mantle beneath its crust. We mapped the inside of the moon by throwing rockets at it. Since 1993, 11 more spacecraft have been deliberately crashed at end of mission. 4 from China, 3 from Japan, 2 American, 1 Indian, 1 European. Some were just disposal, but Lunar Prospector, L-Cross, and India's Chandrayaan-1 used their own impacts as instruments, kicking up plumes and reading the composition of what flew out. Those impacts helped confirm there is water on the moon. And in March 2022, a rocket body left a strange double crater on the far side. It was misattributed to SpaceX at first. A lot of coverage got that wrong, and later identified as a Chinese Long March 3C stage from the Chang'e 5T1 mission. So why does anyone care about one more hole in a surface already covered in them? Because the moon is about to stop being empty. NASA is building toward a permanent presence. So is China. Commercial landers are already arriving. The Artemis Accords, signed by 70 countries, include a requirement that spacecraft and rocket stages be disposed of safely, precisely because uncontrolled objects and inhabited bases are a bad combination. An uncontrolled 4-ton object arriving at 8,000 kilometers an hour is a curiosity when the moon is uninhabited. It is something else entirely once there are people down there. Isaac Mann's own answer is reuse. Spacecraft that become part of the base instead of becoming debris. Whether that arrives before the traffic does is the open question. Nobody launched it at the moon. Nobody could stop it. The sun and gravity worked on a piece of dead metal for 18 months, and it left a permanent mark on another world. The crater will still be there in 1,000,000 years. There's no wind up there to erase it. Subscribe. I'll cover the LRO images when they land.